Hello everyone. Now we are going to see the photoresistor sensor working. This is also simple circuit. I will just show you the demo. I will show you the demonstration of. I'm skipping the loading part. It's a photoresistor also called LDR light emitting diode. Uh, this is also the same connections where we have earlier seen for the flex and for the force sensor. We have used the resistors for pull-up values it will give, and it was connected to the analog A5 pin because it's an analog sensor. So um, I'll it have two conditions. One is the darkest condition I have chosen. Another one is the lightest condition, where if light falls in the photoresistor, it will glow this green LED, and if uh, the light is doesn't present in that environment, then it will glow the red LED. I will just show you how the code will written. We have used pin mode as 12 and 10 for the output of this pin. I don't know why I have written 10. Just let us it. I, we are not using pin 10. Yeah, here we have written pin mode A5 as input because we are taking the values of analog values of this LDR or photoresistor by this analog pin A5 to read that values, and to know the value what is provided to this A5 pin, we need to check on the serial monitor. To start the serial monitor, we need to write this command as serial.begin and with the baud rate 9600. Mm. Here in the looping part, again we are initializing a variable called val, and it will store the value of the value of which is provided by this photoresistor through the analog A5 pin. By this, we are taking here a digital read, but it actually an analog read. So I'm changing this value to analog read. If we return here digital read, it will just read as high or low. That's why we have written high or else if conditions where other values will. But it is not in the case where if we are right. I will just show you once working with digital, and I will change after it when it is. I will show you the analog values also. For this digital read value, it will just read the value as high or low. Means as digital means 0 and 1, it will just read 0 or 1. I will just show you the simulation where if I have written that if value is high, it will glow the 12th pin, means it will give the pulse with high value to 12. This LED is glowing as you are seeing when I am started simulation because uh, it is in the dark condition. I'll just show you. It is in the dark condition. When it is in the light, when light falls on it, it will glow the green LED, which is this conditions where if the value is not high, I have written nothing written means else condition means if value is not equal to high, then it will give the 11th pin as higher but 12th pin as lower, and with the delay of 1000 means 1 millisecond. Here the serial monitor, we are reading the value as 0 because the light is falling on it, and that's why we have written digital read, so it is not showing any other values rather than 0 and 1. If we are in the dark conditions, it will serial monitor will read as 1, and due to the delay of 1 millisecond, it will delaying printing the values with a 1 millisecond delay, and LED is glowing is the condition according to it. Now coming to the shop simulating this, and if I will show you the analog values, I will just change this value digital name to analog like this. Here I am storing the analog reading of A5 and I am storing the value in value 5. I don't know what is the value to provide for to glowing that LED. So I'm just erasing this condition. I'll just let it be. First of all, it is a case sensitive, so I need to write high. Yeah. I will just check the serial monitor for the values it is providing for the each darkness points. I will just show this. Here it is showing 1017 when it is in the dark conditions, and when I am changing the values to middle, it's not exactly middle. It is decreasing to the value to 479 means 500, and when it is in the full brightness conditions, it is giving 344. So we have the range of 1000. We have the range of 1017 to 344. So uh, I just choose the value it is storing. If the I need to first stop the simulation first. Yeah, to edit in the code. If the value is greater than 500, this condition will satisfy, means this condition will execute. Else, if because I have another condition, so I'm writing this if conditions here. If else if value is less than 500, then this condition will satisfy. So let us execute this code now. This code is started simulated successfully, and it is more than 1017, which is more than this condition, previous condition, where if variable val is greater than 500, then LED 12th will get high. Mm, For this condition, this 12th will get high because it is giving 1017 value. When I'm moving this, means I'm providing light to this register, the values will decreasing, and if the value is decreased with and less than 500, where we are getting this value here 422, which is less than 500, and the LED will glow, LED glowing will changed. Here, how we are changing the we are choosing the values here. This is all about the photoresistor sensor. Thank you.